So this video is all about two forces that we know quite well here on Earth. And what I would like for you to do first is to take a look at all of these different forces. Friction, gravity, electricity. A spring force comes from a spring. The normal force is opposite of gravity, magnetism, and then the applied force is any force that you apply. What I would like for you guys to think about is, does this force require contact or can it act over a distance? So think about that question. So friction, is it contact or non? Contact, or friction actually requires contact. If the two materials are not in contact, then the force of friction will not be acting. Gravity obviously does not require contact because two planets can have a gravitational force on each other but not be in contact with each other. Electricity also does not require contact because if you rub your socks on the carpet and then you go to touch a doorknob, you can be shocked before you actually touch the doorknob. So the distance is really small, but it does not require contact. Spring force does require contact between the two objects. The normal force also requires contact. So in order for your chair to apply a force on you, you have to be in contact with the chair. Magnetism, again, it's kind of like electricity where the distance has to be really, really small. But if you put two magnets close together, they don't have to be touching in order for you to feel that force. The applied force is the one that you apply, and you have to have contact with the object. So if I were to apply a force to my computer, the computer is not going to feel the force of my hand unless I actually make contact with the computer. Gravity is something that we know really well here on Earth, and it's a force that pulls objects towards each other. Now, your weight is a measure of the amount of gravity on the object, so it really depends on where you are. Your weight here on Earth is going to be different than your weight on the moon. Your mass will probably be the same between here and the moon, but your weight will be different. The way that we can calculate weight is that weight, which stands for W, equals mass times the gravity. Because gravity is always here on Earth, that's going to be a constant number. The law of universal gravitation says that the force of gravity acts between all objects in the universe that have mass. So if it's an object that has mass, it's going to have a gravitational pull towards any other object. So we are attracted towards the Earth, and the Earth is actually attracted towards us because we have mass. But if you compare our mass to the mass of the Earth, it is so small that we're not going to be able to change the Earth's motion. There are some factors that affect gravity. The first one is mass. The more mass of the object, the stronger the gravitational pull. So your weight is going to be a lot greater on Jupiter than it will be on Earth. And here's a cute little graphic to display that, where this dog here on Earth has a weight of 60 newtons. And again, the way that you calculate the weight is that you take the mass times the gravity. And then the moon, because the moon is a less massive object, the dog is going to weigh less on the moon. But then on Mars, you can see that Mars is bigger than the moon, but not quite as big as Earth. The acceleration due to gravity on Earth is 9.81 meters per second squared. Sometimes you will see this rounded to 10, but it doesn't need to be. And this is a constant number as long as we're talking about Earth. The other factor that affects gravity is the distance. So the greater the distance between these two objects, the less force there will be. Friction is another force that we're going to talk about today. We know it very, very well here on Earth. And it's a force that opposes motion between two surfaces that are in contact. So if you look at this diagram, you can see that there are a whole bunch of microscopic hills and valleys no matter how smooth the surface is. And so when these two things slide over each other or come in contact, they're actually going to kind of stick together. Now, there's two things that affect the force of friction. It's the type of surface that's involved and how hard they're pushed together. Obviously, you know that the rougher the surface, the greater the friction force because the deeper and higher those hills and valleys are. So sandpaper is going to be have a greater force of friction than the ice will. The other thing is how hard they're pushed together, and that can depend on the heavier objects. So if you have a heavier object, that means that the force is going to be greater. Also, if you push surfaces really hard together, the stronger the force of friction will be. So do me a favor and put your hands together and just very gently rub your hands together. Okay, now stop, keep your hands together, and now push your hands together really, really hard, and now start rubbing your hands together. You can feel heat coming from your hands because the force of friction is a lot greater because you are pushing your hands together harder. There are 4 basic types of friction. These can be found on pages 106 through 107 in your textbook. Sliding friction occurs when 2 solid surfaces slide over each other. Fluid friction is anything that's air or water. So if it's not a solid object, then it's going to be fluid friction. Okay. Fluid friction is a little bit easier to overcome than sliding friction is. And then the next one is static friction. This acts between objects that aren't moving. So if you're thinking about like pushing a couch across the room, you can apply a force to the couch, but if the couch doesn't move, then that's static friction. The last one is the easiest one to overcome, and that's rolling friction. So anytime that you have wheels or anything that rolls like ball bearings or anything like that, that's going to be rolling friction. And that's the easiest one to overcome. That's why a lot of times when you're moving heavy furniture, you're going to use something that has wheels because it's going to be easier to move. So here are some questions that I would like for you guys to think about. So pause the video and kind of jot one of these down. Okay, so in what ways is friction helpful? In what ways is friction harmful? What are some ways to reduce friction? And what are some ways to increase friction? So friction is both friend and foe. Friction can be both harmful and helpful, so it's probably necessary to know how to increase or decrease it. So I tell this story every year, but when I was growing up, I lived in the country and there was a creek that ran through our property. And so in order to get to the main road, we had to cross the bridge. Now, during the winter, my mom always kept a bag of kitty litter in the back of her car. And on some days when it was really cold and just slightly damp, the bridge would probably ice over a lot faster than our driveway would. So my mom would take the kitty litter from the back of the car and spread it over the bridge. Now, the reason why she did that is because she understands friction. Because the rougher the surface, the greater the friction is. And obviously, you want friction between the tires and the bridge so that we don't slide off the bridge. The other way to increase the force of friction is to increase the applied force, or like you can use more force. So you can push your hands together harder, or you can use more force when you're sanding. There's obviously going to be some times when you'll want to decrease friction. You know this when your shoes are really, really old, because you'll notice that the soles of them are kind of worn out, because what happens is when 2 things are constantly rubbing together, that can either create too much heat or it could start to wear down things over time. So it will actually change the shape of the surface. So some ways to decrease friction could be to use what we call a lubricant, like oil, wax, or grease. And if you're in band, you'll know this because a lot of times you'll use a lubricant to prevent wear and tear on your instrument. The other thing is you could change the type of friction involved. You can use rolling friction, like ball bearings, or you could just change the surface.